Welcome to this class. In this session, we introduce the concept of quadratic forms. So the quadratic form are defined as a homogeneous polynomial of second degree in any number of variables. So that's what we say. And then next thing, so let's give examples. So for example, one in two variables, we have q of xy. So assuming that the two variables are xy, ax squared plus 2hxy plus b y squared. And number two, in three variables, assuming I have three variables, x, y, and z. So you say the quadratic form x, y, z is a x squared plus 2hxy plus b y squared plus c z squared plus 2 g y z plus 2 f zx. So that's what we have. And then in four variables, we'll have the quadratic form x, y, z, w will be ax squared plus b y squared plus cz squared plus dw squared plus 2hxy plus 2gyz plus 2fzx plus 2lxw plus 2nzw. So this 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2h, 2f, 2g, 2l, 2n, and then we have 2m y w. And so you see, we only have 26 alphabets. And then if we have to extend to more than 26 variables, we'll have a problem on notation. So therefore, the notation X, Y, Z is not the best notation that can allow us to rewrite as many variables as we can. So therefore, and then we say etc. In n variables, we denote the quadratic form as q of x1, x2, x3, up to xn, where n is any positive integer. So n may be 10, 30, 100, a million, etc. But from what you have written here, the examples of these quadratic forms, q of x, y is ax squared plus 2h xy plus by squared. And then this example we have given in 3 variables, and then this example we have given in 4 variables. We may not clearly see how the tools are coming in or how the structures are coming in. So maybe you have performed some miracles here to be able to know how this equation or this form comes into existence, how this equation comes into existence, and how this equation or this expression comes into existence. You shouldn't worry. Let's try to explain how those equations are obtained. So in 2 variables, so just to make it clear for you to understand what's happening, let's do the analysis on how we obtain Q. That's how we obtain the quadratic form. Let's start with the case of 2 variables. So assuming I use the notation 2 variables x and y, then you can draw a table x, y, and write here x, y. Now then you fill this sample space. X by x is x squared. X by y is xy. Y times x is yx. Y times y is y squared. And then this can be written as remember now this in matrix form. So you can duplicate this and say that if I have x1, x2, then I draw the same table. I have x1, x2, x2, x1. So x1 this x1, this x2, just to be consistent. X1, x2. So x1, x1 will give us, can say x1, x1. This will be x1, x2. This will be x2, x1. This will be x2, x2. So this by this, which is the same thing as saying this table has x1, x2, x1, x2, x1 by x1 is x1 squared, x1 by x2 is x1, x2, x2 by x1 is x2, x1, x2 by x2 is x2 squared. If you remember the notation of a matrix, we denote a 2 by 2 matrix by A11, A12, A21, A22. This is how we denote a 2 by 2 matrix. So now, in this expression here, so we might have coefficients. So we have ax squared, and then plus, this and these are just the same thing. So that's why we have 2, and then times a scalar h xy, and then plus b y squared. So this is q of xy. So if you use this notation, in this notation, you'll have a x1 squared plus this and these are just the same, x1, x2, x2, x1, they're the same things. So I'll have 2, say h, x1, x2, or we can use the coefficients. So that we have some consistency in labeling, we write this as A11 x2, and then plus this position is A12 x1 x2. This position is A21 x2 x1, plus this position is A1 A22 x2 squared. And you see, this is the same thing as saying A11 x squared. This and this are just the same thing. So we say into brackets A12 plus A21, and then x1 x2, and then plus A22 x2 squared. So this is a quadratic form of x1 x2. So that's how this one is obtained, and then this is how you write the general term for x1 x2. For when we have 3 variables, x, y, and z, then you write x, y, z, x, y, z, and so this by this is x squared, x times y is xy, x times z is xz, y times x is yx, y times y is y squared, y times z is yz, z times x is zx, z times y is zy, z times z is z squared. Now, because product of x, y, and y is the same thing, that's why we write this one as x squared. So we write coefficient a plus this and this are the same, so we write 2h xy. This and this are the same, so we write 2g xz, plus this and these are the same, so we write 2f yz, plus this one y squared, we write it b y squared, and then this one we write c z squared. So this is what gives the quadratic form in x, y, and z. But when we use variables x1, x2, x3, then it comes out clearly. x1, x2, x3, x1, x2, x3. Now this by this will give us x1 squared. This by this will be x1, x2. This by this is be x1, x3. This by this will be x2, x1. This by this will be x2 squared. This by this will be x2, x3. This by this will be x3, x1. This by this will be x3, x2. This by this will be x3, x3. And labeling becomes easier if you relate it to the way we write a 3 by 3 matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. There's some correspondence between this notation and this notation here. You see here is x1 squared is x1, x1, so A11, x2, x1, x2, A12, so number 1, 2, x1, x3, A13, x2, x1, A21, x2 squared is like x2, x2, so A22, x2, x3, A23, x3, x1, A31, x3, x2, A32, x3, x3 or x3 squared, which is A33. So this one, just write it as square. So then now you write the quadratic form Q of x1, x2, x3 will be, now the position here is A11. So you write A11 x1 squared. This is A22. So you write A22 x2 squared. The position here is A33. So you write A33 x3 squared plus the position here is A12 and then x1, x2. The position here is A13 x1, x3. The position here is A21. So A21 x2, x1. This we have already written. And then the position here is A23 x2, x3. The position here is A31. So you write A31 x3, x1 plus the position here, this we have already taken care of, A32 x3, x2. Now you can write this one as your quadratic form of x1, x2, x3 is nothing but, now you write A11 x1 squared plus A22 x2 squared plus A33 x3 squared plus, now you see product x1, x2 is the same as x2, x1. So you can write A12 plus this one is A21, and then you multiply by just x1, x2 plus x2, x1 is what has gone or has been combined with that term. And then x1, x3 and x3, x1, they're the same. So just have A13 plus A31, and then you multiply by x1, x3. So taken care of this, taken care of this. Now x2, x3 and x3, x2 is the same product. So we write A23 plus A32, then you multiply by x2, x3. So this is the quadratic form for 3 variables, x1, x2, and x3. You see, when you use the notation in matrix form, it becomes easier to express those terms. And let's now discuss for 4 before now we break. So 4 variables, if I have x, so 4 variables, assuming now I start with the x, y, z, and w. So just make a table. Say this is x, this is y, this is z, this is w. X, y, z, w. And let's fill in these spaces. X by x is x squared, x by y is xy, x by z is xz, x by w is xw, y by x is yx, y by y is y squared, y by z is yz, y by w is yw. Z by x is zx, z by y is zy, z by z is z squared, z by w is zw. W by x is wx, w by y is wy, w by z is wz, w by w is w squared, which is the same thing as writing. We are interested in this structure: x squared, xy, xz, xw. This will be xy the same as yx, yx the same as xy. So x, y, z, w, x, y, z, w. So this is the same as xy, y squared, yz is the same as yz, and then yw. And then here, zx is the same as xz, so just write xz. And then yz the same as zy the same as yz. And then z squared is the same as z squared. Zw the same as zw. Wx the same as xw. Wy the same as yw. Wz is the same as zw. And this is w squared. So you see in this structure, this element here and this one are the same. So there are 2 of them. That's why we have 2 in that formula. This element here and this element here, they are the same. So that's why we have 2 in the formula we gave. This element here is the same as this element here. That's why there are 2 of them in the formula. And then this element here and this element here are the same. So that's why you have 2. And this element here is the same as this element here. And this element here is the same as this element here. So that's why we say that Q of x, y, w, so i.e. quadratic form in x, y, z, and w is written as, so you take a scalar multiplied by x squared, take a scalar multiplied by y squared, take a scalar multiplied by z squared, take a scalar multiplied by w squared, take a scalar now, because now each of these mixed ones are 2 of them. So that's why we have 2h xy. So this is a scalar, and then these 2 because there are 2 of them, plus 2 g yz plus 2 f zx plus 2 l xw plus 2 myw and then plus 2 NZW. So that explains where those two are coming from. But the structure is better when you label your variables as xi's. So if we deal or we work with 4 variables, x1, x2, x3, x4, then we write this structure: x1, x2, x3, x4, x1, x2, x3, x4. And now we fill this sample space. X1 times x1 is x1 squared. X1 times x2 is x1, x2, x1, x3, x1, x3. This will be x1, x4. This will be x2, x1. This will be x2 squared. This will be x2, x3, x2 then times x4. This by this will give us x3, x1. This by this, x3, x2. This by this will be x3 squared. And then this is x3, x4. Here we have x4, x1, x4 by x2 is be x4, x2. This will be x4, x3, and this will be x4 squared. Now, if you compare this correspondence and the way we label a 4 by 4 matrix, so this is A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, A41, A42, A43, and then A44. You see that there's some pattern on how the xi's are formed in the table here, and this general way of labeling elements in a 4 by 4 matrix. You see x1 squared is like x1, x1, so A11. X1, x2, this position is A12. X1, x3, this position is A13. X1, x4, this position is A14. X2, x1, this position is A21. So there's that semblance. So this will be take every element times its corresponding position from this general way of writing the 4 by 4 matrix. So we write Q of x1, x2, x3, x4 will be A11 times x1 squared plus, now you see product x1, x2, and x2, x1 is the same, but x1, x2 goes with A12, and then times x1, x2, this one goes with A21, and so x1, x2 plus, so we have taken care of this, Okay, maybe the best way, let's just write all the main diagonal elements first before now we go to the off diagonal elements. So this other one for this one will be A22 x2 squared. This one will be A33 x3 squared. This one will be A44 x4 squared plus, now what I said, this is the same as A12 plus this one is A21, then you multiply by x1, x2. So taking care of this, and this one here, and this one will give us A13 plus A31, and then you multiply by x1, x3. So these are taken care of. Next one, let's go to this. This x1, x4 is the same as x4, x1. So we'll have A14 plus A41 multiplied by x1, x4. X1, x4 plus, so this is taken care of, this is taken care of. Let's go to this. X23 and X32 will be the same. So we'll have A23 plus A32. Then you multiply by X2, X3. So this one and this one taken care of. Let's go to X2, X4. So we'll have A24 plus A42. You multiply by X2, X4. So this one and this one taken care of. And lastly, this one will have A34 plus A43. You multiply by X3 and X4. So this is how we write the standard quadratic form involving 4 variables, X1, X2, X3, and X4. In the next session, we discuss further on how to transform a quadratic form into matrix form. Thank you.